Good afternoon, AP Physics students. I need to show you guys a little supplemental video from the quarantine jail that I'm stuck in about the lab that you're going to do today. So on your lab, I don't specifically tell you which masses to use, but I start with at least like that 200 grams because anything less than that really won't stretch the spring that far. So I'd start with at least 200 grams. Get enough data points to fill that in. You kind of want the farther apart your data points are, the better off you're going to be. So I'd maybe start minimum of 200, and then I'd go maybe like 500, 800, whatever you want to do. But you want to get a pretty good spread on that data. So the first graph that you're going to do on that front is you're going to have elongation here, and you're going to have force here. You're going to have your data points. Draw that line of best fit. You're going to find that slope. You're going to have meters per Newton. Okay, so that's the first one that you guys are going to do. Then, on the second graph that you're going to do, on the back side of this thing, you're going to do a second graph where you're going to put force here and elongation here. That will allow you to actually calculate what's known as the spring constant, which we will use later again in a couple of labs throughout the year. And you're going to find that slope. If that goes well, typically with these springs, you should get a slope of around 80 newtons per meter. Okay, it's an ish, but it should be something around there. Now, you're also going to be asked to find the area. So in the lab, I'll tell you that you're going to come out here and you're going to use your maximum elongation. Okay, so that's what you want to go off. So when you've got, yours isn't orange, but you're going to go down here and you're going to find that maximum elongation that you have. Okay, so whatever that is, let's say it's 0.2 meters. Okay, so you're going to go out here to that 0.2 meter mark. Then you're going to draw a line straight up and you're going to base it upon where it crosses the line of best fit. Not necessarily the force that goes with it, but it's where it crosses that line of best fit. So you're going to come out here, use your elongation as your base, go straight up, see where it crosses your line of best fit, use that point as your height, and then calculate that area underneath there. Okay? So that's going to be a key thing to look at. So that's going to be the difference between what you guys have to do in terms of relative to my honors physics kids. So you're going to have two graphs, elongation, force, then you're going to switch it, you're going to have force, elongation here, and then you're going to find that area underneath there. So if you have any questions, feel free to email me, because believe me, I'm kind of going to start crazy. Anyway, quarantine is not a good time, and the irony of it is, I feel fine. God, I wish I was with you guys, but hey, this is the hand that we're dealt. So good luck, and can't wait to see you guys on Tuesday.